Today we're looking at a study that examines what happens to a worker's performance when they use an algorithmic tool. It offers a specific view on the collaboration between human experience and artificial intelligence.
So here's the central question the research gets into. If you want to get the biggest performance boost from a new AI tool, should you hand it over to your most senior, most experienced employees? You'd think the answer would be a simple yes.
But the findings from this particular study suggest a more complicated answer. The data indicates that just giving an AI tool to your experts doesn't always lead to the biggest performance gains.
To understand why, let's first take a look at how the experiment was set up. Okay, so the experiment involved 153 IT support workers at a large tech company. Their job was pretty straightforward: resolve technical help tickets. They were given an AI tool called Automate IT, which was designed to recommend solutions. Now, a really key part of the design was that every single worker resolved some tickets the old-fashioned way, manually, and others using the new AI tool. This meant the researchers could directly compare their performance, and success was measured simply by the percentage of tickets they managed to resolve correctly.
So what did the performance data actually show? Well, the results revealed a very distinct pattern when workers were using the AI.
If you look at the chart on the left, you can see manual performance. It's pretty flat. Workers with more experience were a little bit better, but not by a whole lot. Now, the chart on the right shows performance with the AI tool. And here, a clear curve pops out. Performance goes up with experience, hits a peak right in the middle, and then actually starts to decline for the most experienced workers.
So this is the crucial point. When you plot the difference between AI-assisted and manual performance, in other words, the actual performance boost from the AI, you get this inverted U-shape. The greatest benefit from the AI tool went to workers with a moderate level of experience. Both the beginners and the most seasoned experts saw a much smaller boost.
So why does this happen? The researchers came up with a framework that's based on two competing forces. The first force is ability. This is the skill to work effectively with an algorithm, to spot its mistakes, to correctly interpret its advice, and apply it properly. As a worker gains experience, their ability to do this goes up. But the researchers theorize that it happens with diminishing returns. The leap in ability from year 1 to year 2 is bigger than from year 10 to year 11.
The second force is aversion. This is the tendency to ignore an algorithm's recommendation and instead just trust one's own judgment. According to the theory, this tendency to reject the AI's advice grows steadily stronger as a worker gains more and more experience.
This slide helps visualize the theory. The top panel shows the two forces. The green line represents ability, which rises pretty quickly at first and then starts to level off. The red line, representing aversion, just increases at a steady, linear rate with experience.
Now, the bottom panel shows what happens when you combine these two forces. You've got the positive effect of ability and the negative effect of aversion, creating the net impact on performance. The result is that dotted blue line, the same inverted U-shape that was observed in the experimental data. In the middle, the gain from ability is much larger than the drag from aversion, but at the high end, aversion has caught up, pulling performance back down.
The study then dug into the evidence for these ideas. Why exactly did the workers at both ends of the experience spectrum fail to get the most out of the AI tool? For the low-experienced workers, the issue really seemed to be a lack of ability. If you look at the data on the left, you can see that while the AI provided correct recommendations at a high rate for everyone, the least experienced workers had the lowest success rate in actually picking the correct recommendation and resolving the ticket. Interviews suggested they just didn't have the knowledge to evaluate if the AI's advice was correct, so they often rejected it. For the most experienced workers, it was a different story. It wasn't about a lack of ability, but a sense of caution and accountability. As this one worker with 13 years of experience put it, we cannot blindly run the executor script or runbook. They felt a responsibility not to just follow the AI's recommendation, and they worried about potential unintended consequences. The data on ticket difficulty offers even more evidence. The low-experienced workers, on the left, tended to give up on tickets that were, on average, more time-consuming to solve. This is consistent with a lack of ability. The high-experienced workers, on the right, released tickets that were no more difficult than the ones they attempted. This suggests their decision to reject the AI's help wasn't based on how hard the ticket was, but on something else, and that something else was likely aversion. This provides a clear illustration of that underlying ability. When the researchers looked only at the tickets the workers attempted to solve, basically filtering out the aversion effect, a different picture emerged. Here, performance with the AI tool increases steadily and linearly with experience.
This indicates that when the experts chose to use the tool, their deep domain knowledge did in fact help them use it more effectively. The problem was their tendency not to use it in the first place.
So, what are the practical takeaways from these findings when it comes to designing effective human-AI work processes? The study suggests that a one-size-fits-all approach to AI implementation probably won't be effective. For low-experience workers, the focus should be on interventions that build their ability to evaluate and use AI advice correctly. For high-experience workers, the challenge is different. They likely need interventions that reduce their aversion, maybe by giving them more transparency into how the AI works or more control over its actions.
This research leaves us with a question to consider. As algorithms become a standard part of more and more jobs, the findings here suggest we may need to rethink not just how we train new employees, but also how we train and support our most experienced ones to collaborate effectively with these new tools.